Hey guys, so in the last lecture we have seen few IS standard codes and what are their functions, what are that code means, and we have also seen indicated power and how to measure indicated power. So today we will move further. We have also seen equation to calculate indicated power. So today we move further and see the next topic, that is brake power. How to measure brake power, what is the formula for brake power. So we'll start with first, that is measurement of brake power. So measurement of brake power is important test carried out in the test schedule of an engine. So it involves the determination of the torque and the angular speed of the engine output shaft, and a torque measuring device that is called dynamometer. That torque measuring device is called dynamometer. So let's draw the dynamometer. So suppose this is the rotor. Rotor means wheel which is rotating, and we need to measure the torque. And suppose this is the stator, another circular element. We'll call it as a stator. So this is stator and this is rotor. This is stator, this is rotor, this is stator, and in between there is a coupling force. So in between there is coupling force. So in here, suppose we are applying a counterweight balance, but it is countering what? So it is so on this in opposite side of the counter weight balance, so we will introduce a scale, so it will counter the scale. So whatever value of that weight, it will show here in this scale. So here it will be the counter weight balance, and this will be the scale. So, and suppose the distance between this center and the scale is suppose L. So this figure shows the basic principle of dynamometer. So it is a rotor driven by the engine. So this rotor means the wheel is driven by engine, and the test is mechanically, hydraulically and electromagnetically coupled to a stator. So it is coupled to the stator. So for every revolution of the shaft, the rotor periphery moves through a distance of 2 pi r. So for every revolution, so one revolution will be the distance for the one revolution. So the distance for the one revolution is 2 pi r. So the coupling force, that is work done, is, so what will the force, so what will the work done? So as we know, work done is equal to force into distance. So force into distance, how much distance it has traveled, that is 2 pi r. So the work done is 2 pi rf. So the external moment or torque is equal to, so this is equal to the torque generated. So what is the torque? So now if I take moment on this both the sides, so suppose, so first moment on this side. So here the what is the formula for moment? Moment is force into distance. So if I take the moment, so here force is shown in the scale, reading scale, so that is scale into length L. And on the right hand side, what is the force? So force here is this radius, So that is the radius r into force, coupling force. So here the coupling force which is acting, this coupling force. So that force, so that force into r. So what will be the formula? So if I take the external torque and moment is equal to S into L. So what is S? So S is the scale reading into distance from a scale reader to the center of the axis, which is equal to the moment, that is R, that is radius into coupling force. So here torque is equal to moment we have taken. So therefore, so the formula, that is work done. What is the work done formula? So that was 2 pi rf. So instead of rf, we can write SL. So we can write W is equal to 2 pi SL. And so the brake power BP can be given as 2 pi NT. So it can be given as 2 pi NT. So what is T? So T, sorry, so the T is this S into L. So this torque is T. And what is N? So if we are taking this work, this brake power in terms of uh, RPM, so this N if we are taking is in terms of RPM, so that will be 2 pi NT and watts. So this is the basic principle of dynamometer. So there are so many types of dynamometer. So I will just list the classification. So suppose dynamometer. So it can be divided in two types. It is absorption and transmission type. And in absorption type dynamometer, there are three types, that is mechanical friction type, hydraulic, and electric. And in transmission type, there are three: belt, epicyclic, gear gear train, and torsion. And in mechanical also there are two types. So there is prony brake and rope brake. And in electrical there are three types. So first is eddy current, swinging field type, and motoring eddy current type. So these are the various dynamometer which are used for different applications. So the concept of the dynamometer is of for the are the same, the principle. So there is just construction and construction difference in each and every. The principle remains same. So now we will see the next topic, that is friction power. So what is friction power? So we have seen indicated power and we have seen brake power. So indicated power is the power generated from the system, and brake power is the power which at the end the user experiences. So in between there is loss of power, and that power difference is called friction power. So the difference between the indicated power, so I can say friction power is equal to the difference between indicated power and the brake power is known as friction power. So now how we can define these losses, that is, what are the reasons for these losses. So the internal losses in the engines are essentially of two kinds. So first is pumping loss, and other is friction losses. Other is friction losses. So during inlet and exhaust stroke of the gaseous pressure on the piston is generated on its forward side and underside during the inlet and upper side during the exhaust stroke. Hence, during the stroke, both strokes, the piston must be moved against a gaseous pressure, and this is called as pumping loss. So that loss is called pumping loss because the piston is being moved against a gaseous pressure. So this loss we are not discussing, we are discussing friction loss, but this both are two losses which accounts for the friction power. So the friction loss is made up of friction between the piston and cylinder walls, piston rings, cylinder walls, and between the crankshaft and camshaft, their bearings, as well as loss incurred by driving the essential accessories such as water pump, ignition unit, etc. So it should be the aim of the designer to have minimum loss of power in friction, and the friction power is used for the evaluation of indicated power and mechanical efficiency. So following we will discuss uh, methods. So methods used to find the friction power to estimate the performance of the engine. So there are four methods. For friction power, so there are total four methods. So first is Williams method. William Williams line method. The second is Mohs test. The third is motoring test. And the fourth is the measurement of indicated power and brake power. So after measuring indicated brake power, we will get the friction power. And the last is retardation test. So we will see this method one by one. So let's start with Williams method. So we will start with Williams line method. So in Williams line method, gross fuel consumption versus gross fuel consumption versus brake power at a constant speed is plotted, and the graph is extrapolated back to zero fuel consumption. So let me draw the diagram. So suppose this is engine torque, and this is fuel flow rate, that is gas per second. So suppose this is the graph, so this is extrapolated here, that is, suppose here this is minus 20. So this, what value we are getting, so this is the friction torque. So here then again 0, 20, 40, 60, 80 and 100, and here the fuel flow rate, that is 0, 0.2, 0.4, 0.6, 0.8, and suppose 1, sorry, 1 and 1.2. So this graph is plotted. So here the point where this graph cuts the brake power axis in an it is the indication of the friction power of that engine at that speed, and the negative work represents the combined loss due to mechanical friction, pumping, and blow by. So the petrol engine, we keep the air fuel ratio mixture constant and vary the amount of mixture intake for required torque or power, and this is called quantitative governing. In the diesel engine, we draw a constant volume of air compression and vary the fuel injected, and technically we alter the quality of the fuel air quality of the air fuel mixture. This is called qualitative governing. So in SI engine at low speed, the air mixture intake is very low. Hence, hence there will be a low pressure region created inside the cylinder, due to which there will be a pumping loss. Therefore, there will be more friction power than actual. We get an erroneous output if we use Williams lines test for SI engine. So if we use the same test for CI engine, so there is qualitative governing, and hence there will be a fixed amount of air entering the cylinder and no negative pressure and pumping losses occur. So we can relatively closer the value of friction power. The errors are greatly minimized. So Williams-Lines method is applicable only to diesel or CI engines. Now, what are the drawback for this method? So the drawback for this method is the long distance to be extrapolated from data measured between 5 to 40% load towards the zero line of the fuel input. So the directional margin of error, the directional margin of error is rather wide, because the graph which may not be a straight line many times. So the changing slope occurs. The changing slope along the curve indicates part efficiency of the increments. The another drawback is that there is a slight curvature at the light loads, and this perhaps due to difficulty in injecting accurately and consistently very small quantities of fuel per cycle. And therefore it is essential that great care should be taken at the light loads to establish that true nature of the curve. The Williams lines method. So this Williams lines method for swivel chamber CI engine is straighter than for a direct injection type engine. So the accuracy obtained in this method is good as compared to favorably with other methods if extrapolation is carefully done. So this was the advantages and disadvantages of Williams lines method. The next method is Morse test. So indicated power of a multi-cylinder engine can be found out by this method. So indicated power of a multi-cylinder engine can be found out with this method. But we cannot find the indicated power for a single cylinder. That is the limitation of this method. Also in this method, the indicator diagram is not required. So for multi-cylinder engine, power developed in any cylinder is cut off and output power, brake power, is measured. So in case the petrol engine, such each cylinder's turn is rendered inoperative by shorting the spark plug of the cylinder, and in case of diesel engine, So by cutting the fuel of the fuel supply to the cylinder successively. So let's consider a four cylinder spark ignition engine. So four cylinder spark ignition engine coupled to a dynamometer. Throughout the test, the engine is run at constant speed at n rpm. So it is assumed that pumping and mechanical friction losses are same whether the cylinder is working or not. So also the throttle position is kept constant throughout the test. So here assumption is taken that pumping and mechanical friction losses are the same whether the cylinder is working or not. Also the throttle position is kept constant throughout the test. So let suppose B is the total brake power of all the four cylinders. So let us suppose B1 plus B2 plus B3 plus B4. And now what are this B1, B2, B3, B4? So these are the brake power of engine cylinder when the cylinder 1 is cut off. So when this is cut off, the B2 is when cylinder 2 is cut off, and this when cylinder 3 is cut off, and this when cylinder 4 is cut off. So the total brake power here, it is 3 times brake power is equal to B1, B2, B3, B4, because if cylinder 1 is cut off, then 3 cylinders are working. Similarly here 2 is cut off, the other 3 are working. So total 3 brake powers is there. So the total brake power, so suppose what will be the formula for total brake power? Total brake formula will be, suppose I1. So now for total formula for brake power, suppose I will just introduce the I. It is the indicated power developed by all the cylinders, and suppose I1 is the indicated power developed by first cylinder, I2 is indicated power developed by second, third and fourth, and similarly F1, F2, F3, F4 are the friction power of all 1, 2, 3, 4 cylinder. But here B1, B2, B3, B4 are not the brake power of first, second, third and fourth cylinder. So this we need to keep in mind. So as a total brake power can be written as that I1, that is indicated power minus frictional power. So what is indicated power? IP, that is I1 plus I2 plus I3 plus I4 minus F1 plus F2 plus F3 plus F4. So these are the frictional power, that is F1, F2, F3, F4 for cylinder 1, 2, 3, 4. So on subtracting, suppose, so now if I subtract B minus B1, so what is B? So B is the brake power of all the four cylinders, and B1 is the brake power when cylinder 1 is cut off. So what I will get? So when all four cylinders are working, and if one cylinder is cut off, so 3 cylinders are working. So we will get the power which would be generated by one cylinder. So that is the first cylinder. So we will get, that is indicated power, that is I1. So when 4 cylinders are working, so at that time what power was generated, and when 3 cylinders are working, at that time what power is generated. So we'll get that how much power uh, is generated will be at when only one cylinder can work. So similarly we'll get B minus B2 is equal to I2, B minus B3 is equal to I3, and B minus B4 is equal to I4. So if I add all the equations, that is I is equal to I1 plus I2 plus I3 plus I4. So what we are getting? So we are getting 4b minus b1 plus b2 plus b3 plus b4. So this friction power, the that is friction power, is I minus b. So as we know that friction power is I minus b. So from this formula we have got the value of indicator power, it is 4b minus b1 b2 b3 b4. So this is our goal, and then we can find the friction power, that is subtracting I from the b, so we can get the friction power. So this is the Morse test. Now what are the errors involved in this? So though the measurement of the frictional power is fairly accurate, however the errors involved in the measurement of frictional power by this method are, it is in petrol engines using common intake manifolds may affect the distribution of mixture and volumetric efficiency of each cylinder, and the use of common exhaust manifolds and the cutting of the cylinders may cause pulsation in the exhaust system, which in turn will affect the performance of the engine. So these are the two disadvantages of this method. Next we'll see Morse motoring test and other tests. So thank you very much.